Alright, so my name is Emilio Soto and I did my presentation on Kirchoffs Voltage Law, otherwise known as KVL. So we'll start off with Gustav Kirchhoff. So Gustav Robert Kirchhoff was born on March 12th, 1824, Königsberg, Prussia, and died on October 17th, 1887 in Berlin. And in 1845, Kirchhoff first announced Kirchoffs laws, which allow calculation of the currents, voltages, and resistances of electrical networks, and this extended the theory of the German physicist Georg Simon Ohm. And so we'll move on to the formal definition. So Gustav Kirchoff's voltage law is the second of his fundamental laws used in circuit analysis, first one being KCL, which is Kirchoff's current law. His voltage law states that for a closed loop series path, the algebraic sum of all the voltages around any closed loop in the circuit is equal to 0. And this is because the circuit loop is a closed conducting path, so no energy is lost. And so if you look at the picture here on the bottom, you see a closed loop circuit, and if you add all the voltages and the voltage source as well, it'll all come out to 0. And so we move on to the conservation of energy. So KVL is often called the law of conservation of energy. So when you move around a closed circuit loop, you will end up back to where you started in the circuit and therefore back to the same initial potential with no loss of voltage around the loop. And so any voltage drops around the loop must be equal to any voltage sources met along the way. So if you look at this picture here on the left, you see several multimeters placed around a circuit with a 45 volt source, a 5 kilo ohm resistor, 10 kilo ohm resistor, and a 7.5 kilo ohm resistor. And so you see the voltage drop right here is plus 45, negative 10, negative 20, and then negative 15. So what you want to do to apply KVL's law is get the sum of all these voltage drops and they equal to 0, proving KVL's law. And so we move on to the mathematical formula. So Vs minus VR1 minus VR2 minus VR3 is equal to 0, Vs being the voltage source. VRs are the voltages through the resistors. So in any closed loop, the algebraic sum of the voltages is always equal to 0. And so we move on to an example. So here we have a circuit with V1 equals 10 volts, V2 also equal to 10 volts, and then 200 ohm resistors. And what they want to know is the current through resistor 1 and the current through resistor 2. And so we'll apply both KVL and Ohm's law to get these currents. So we'll start with the first loop right here, a closed circuit loop. So minus V1 plus voltage to resistor 1 is equal to 0. And this is minus V1 because it is flowing from negative to positive. And so V1 is equal to VR1, therefore making VR1 equal to 10 volts. And so then you move on and apply that into Ohm's law, where IR1 is equal to VR1 over the resistance. And so that comes out to 0.1 amps. And to find the current through resistor 2, you get the entire loop, where after an algebraic step it comes out to the voltage through resistor 2 is equal to the voltage 1 plus the voltage 2, which is equal to 20 volts. And so VR2 is equal to 20 volts. Until you apply Ohm's law again, and you get the current through resistor 2 is equal to the voltage through resistor 2 over the resistance. So you get 0.2 amps. And then we move on to real-world applications. So the KVL and KCL laws are both used quite often in everyday life by people who deal with electrical circuits. One example would be drones. They are very sensitive when it comes to electrical input and output, so KVL and KCL laws are used to calculate these electrical values. And same goes for laptops. They are full of electrical circuits, and KVL and KCL must be used. And here are my sources.